student. Welcome to all of you in the next physics lecture. And this is the video number 18 and the chapter number 2, the mechanical properties of fluids. And we have to see here the next point. This is very important. The expression for the excess of pressure inside the liquid drop. You can ask in your exam. Derive the expression for excess of pressure inside the liquid drop. Then we have to solve this derivation for this excess of pressure inside the liquid drop. First we have to draw the here a spherical drop as shown in figure. This is just a dotted. This is the pressure outside, and Pi is nothing but the pressure inside the drop. We have to consider here the spherical drop as shown in figure. This is the spherical drop. Let Pi be the pressure inside the drop, and PO, this is the pressure outside the drop. We know that if the forces always try to minimize the surface area of the liquid, if a bubble or the drop does not collapse because the resultant of that external pressure and the force of surface tension is the smaller than the pressure inside the bubble or the inside the liquid drop. And so that we have to consider here the drop is spherical in shape, and therefore the pressure, that is the pressure inside the drop, is greater than, that is the PO, that is the pressure outside the spherical drop. That means the Pi is greater than PO, and so that the excess pressure inside the drop is Pi minus P0, because the pressure inside the drop is greater than pressure outside the drop. Therefore Pi is greater than P0. Therefore excess of pressure inside the drop, we can write here Pi minus PO. Now the radius of the drop, which can be increases, radius should be the constant, and so that the radius of the drop increases from R to del plus R, which should be R to R plus del R, and therefore this pressure inside the drop is always constant. Now we have to find out the initial surface area. This is the spherical in shape, therefore initial surface area for the sphere, and this is nothing but the A1 is equal to 4 pi r square. Then the final surface area, and it should be increases by the del r, so that A2 is equal to 4 pi into, instead of r we have to take here r plus del r and bracket square. Initial surface area A1 is equal to 4 pi r square. Final surface area which is increases by the del r, and therefore A2 is equal to 4 pi into bracket, instead of r we have to write here r plus del r bracket square. We have to solve this bracket, expand this square. Then A2 is equal to 4 pi, expansion of this, r square plus 2r into del r plus del r square. Then multiply this 4 pi. A2 is equal to 4 pi r square, 8 pi r del r, and plus 4 pi into del r square. But this del r is very small, therefore this last term 4 pi into del r square, it should be neglected, and therefore A2 is nothing but, that is the final surface area, is equal to 4 pi r square plus 8 pi r into del r. This is the A2. Now we have to find out the increasing surface area of the drop. Now we have to find out the increasing surface area. This is denoted by the letter dA, and therefore we can write here dA is equal to A2 minus A1. See here, dA is equal to A2 minus A1. We know that this A2 is nothing but what? That is the 4 pi r square plus 8 pi r into del r minus A1, that is the initial surface area, and this is nothing but the 4 pi r square. Therefore we can write here minus 4 pi r square. This 4 pi r square, 4 pi r square cancel, and remaining terms dA is equal to 8 pi r into del r. Suppose this is the equation number 1. dA, this is the increasing surface area of the drop, dA is equal to 8 pi r into del r, equation number 1. Now we have to find out the work done in increasing surface area by the dA, which is the stored in the form of excess surface energy, and this excess surface energy in the form of the work done, which is given by dW is equal to T into dA, where this dA is nothing but the increase in surface area and T is the surface tension, so that dW is equal to T into dA is equal to T into dA is nothing but what? 8 pi r into del r. dW is equal to T into dA. We have to substitute here T instead of dA. We can write 8 pi r into del r. And this is the equation number 2. This is the work done. Now, this work done is also given by in the form of force into displacement. And therefore, we can write here dW is equal to F into del r. And this is the equation number 3. We can, comparing this equation 2 and 3, we can find out the F. Further this, we can compare the equation 2 and 3 and then we can find out the value of F, because we have to find out here the excess of force, and which is given by F is nothing but the excess pressure into the surface area. We know that pressure is nothing but what? P is equal to force per unit area. P is equal to FIA. Therefore, F is equal to this pressure into surface area, excess pressure into surface area. Therefore, we have to substitute here excess pressure. We know that this Pi minus Po here, Pi minus Po. This is the excess pressure, and surface area is nothing but the 4 pi r square. We can substitute here this 4 pi r square. And now we can find out this F. How? The comparing the equation 2 and 3, because both are the this dW. Comparing this 2 and 3, equation number 2 and 3, we can compare. Then this del r it should be get cancelled, and F is equal to T into 8 pi r. Therefore, we can substitute instead of F, comparing this to equation 2 and 3, T into 8 pi r, because del r cancel, and F is equal to only T into 8 pi r. Instead of F, we can write T into 8 pi r is equal to Pi minus Po into 4 pi r square as it is. Okay, then we have to cancelize this LHS and RHS. 4 pi, this pi get cancelled, 4 2s are 8, therefore these 2 are there, 1 r square is, and this r, it should be cancelled, remaining r is there, and remaining terms T into 2 is equal to Pi minus Po, simply r, and we have to find out this excess pressure. Therefore, this Pi minus Po is remain as it is, and this r is multiplied. Then instead taken this side, it should be divided. Therefore, Pi minus Po is equal to this 2T upon r. And this equation number 4 is nothing but the excess pressure inside the trough. We have to find out this, the equation Pi minus Po. This is nothing but the excess pressure inside the liquid trough. Now, in case of, we have to consider the soap bubble, and this soap bubble has the two sides, two free surfaces in contact with the air, that is the inner surface and the outer surface, and therefore because of these two surfaces, two sides, we have to take here this change in surface area is nothing but the 2 into 8 pi r into del r. Instead of simply 8 pi r into del r, we have to take here the 2 into 8 pi r into del r. We have to change this. dA is equal to 8 pi r into del r. But we have to consider this in case of the soap bubble. There are the two free surfaces, inner and outer surface. Therefore, instead of this dA is equal to 8 pi r, 8 pi r into del r, we have to write here dA is equal to 2 into 8 pi r into del r. And so that again, F is equal to Pi minus Po into 4 pi r square. Instead of this F, we can write here T into not 8, but instead of multiplying this 2, T into 16 pi r. And therefore, instead of 8 pi r, we can write here 16 pi r, because this 2 we have to take, because of the, in case of the soap bubble, there are the two free surfaces, and therefore 2 into 16 pi r is equal to Pi minus Po is equal to 4 pi r square. Again, simplify these terms, LHS, RHS, we get T into 4 is equal to Pi minus Po into simply remaining term r. And again, we have to find out in case of the soap bubble, the Pi minus Po is equal to 4T upon r. And this is the equation number 5. If you have to consider in case of the soap bubble, there are the two free surfaces, outer surface and inner surface, so that Pi minus Po is equal to 4T upon R. And if you have to consider the excess pressure for the liquid drop, then the Pi minus Po is equal to 2T upon R. And this is equation number 4. And you can remember what you are asked in your exam. This is the expression for the inside the drop, liquid drop, Pi minus Po is equal to 2T by R. But in case of soap bubble, Pi minus Po is equal to 4T upon R. And you remember this and you can understand well. Okay, thank you.